Assalamualaikum and hi. My name is Mohammad Hilmi, 18002378, mechanical engineering student from Universiti Teknologi PETRONAS. In this video, I'm going to present a report which involves control volume about impact of a jet. Throughout this video, I'm going to go through the introduction, objective, methodology, apparatus, procedures, result and calculation, and finally discussion before concluding my presentation. So let's move to the introduction. Moving fluid in natural or artificial systems may exert forces on objects in contact with it. To analyze fluid motion, a finite region of the fluid, which is control volume, is usually selected, and the gross effects of the flow, such as its force or torque of an object, is determined by calculating the net mass rate that flows into and out of the control volume. These forces can be determined, as in solid mechanics, by the use of Newton's second law or by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. The study of these forces is essential to the study of fluid mechanics and hydraulic machinery. So for practical application, engineers and designers use the momentum equation to accurately calculate the force that moving fluids may exert on a solid body. For example, in hydropower plants, turbines are utilized to generate electricity. Turbines rotate due to the force exerted by one or more water jets that are directed tangentially onto the turbine's vanes or bucket. The impact of the water on the vanes generates a torque on the wheel and causing it to rotate and to generate electricity. The objective of the experiment is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface, and to compare the result from the experiment with the computed force by applying the momentum equation. So basically, the momentum force is determined by measuring the forces produced by a jet of water impinging on solid, flat, and curved surfaces, which deflect the jet at different angles. So to conduct the experiment, three apparatus are needed, which are firstly, F110 hydraulic bench, secondly, F116 impact of a jet apparatus with three flow deflectors with deflection angles of 90 degree, 120 degree, and 180 degrees, and finally, stopwatch for timing the flow measurement. So here is the experiment setup. All components of the experiment setup are labeled correctly. Now, I will go through the procedures of the experiment. Firstly, remove the top plate and the transparent cylinder from the equipment and check and record the exit diameter of the nozzle. Then, replace the cylinder and screw the 90-degree deflector onto the end of the shaft. Next, connect the inlet tube to the quick release connector on the bench and replace the top plate on the transparent cylinder, but do not tighten the 3 nail nuts. Next, using the spirit level attached to the top plate, level the cylinder by adjusting the feet. Then, replace the 3 nail nuts, then tighten in sequence until the built-in circular spirit level indicates that the top plate is horizontal. Do not over-tighten the nail nuts, as this will damage the top plate, and the nut should only be tightened enough to level the plate. Then, ensure that the vertical shaft is free to move and is supported by the spring beneath the weight pan. Next, with no weights on the weight pan, adjust the height of the level gauge until it aligns with the datum line on the weight pan. Check that the position is correct by gently oscillating the pan. Place a mass of 50 grams on the weight pan and turn on the pump. Then, open the bench valve slowly and allow water to impinge upon the target until the datum line on the weight pan is level with the gauge. Leave the flow constant. Then, observe and note the flow behavior during the test. Measure the flow rate using the volumetric tank. This is achieved by closing the ball valve and measuring the time that it takes to accumulate a known volume of fluid in the tank as measured from the side glass. But remember that you should collect water for at least 1 minute to minimize timing errors. Repeat this procedure by adding an additional 50 grams incrementally until a maximum mass of 500 grams has been applied. Then, repeat the entire test for each of the other two flow deflectors. Moving on, here is the raw data table to collect the data from the experiment. And please take note that the value of the diameter and cross-sectional area of the nozzle should be 0.008 meter and 5.0265 times 10 to the power of 25 meters square respectively. For each set of measurement, calculate the applied weight, flow rate, velocity square, force, and theoretical and experimental slope of the relationship between W and V square. For theoretical slope, it is determined by using the equation from the slide, and for the experimental value of S is obtained from a graph of W plotted against V square. And here is the result table after calculating all the desirable value. Then, graph of forces against flow rate are plotted. Next, moving on to discussion, as the flow rate will increase, the force resulted from the impact of the jet on both of the flat plate and the hemispherical cup is increased too for the predictor of F1 and the measured F2 values of force. This relation can be seen clearly from the plots in this report, and this result was already predicted from the change in momentum equation of calculating the force. As for a conclusion, the impact of the jet forces on the flat plate were half of in on the hemispherical cup. The result is displayed clearly in plot 1 and plot 2 for both predicted and measured values of the force. And this was predicted already from the equations of momentum for calculating the forces. And for the last point, the hemispherical cup is more efficient for using in a turbine than the flat plate. But it is only one point to be considered is that the water exit the cup is going to collide with water entering the cup, which will reduce the force. And that's all from me. Thank you.